ಓಪನ್ ಆಗ್ತಿದೆ ಸರ್. ಹಾಂ ಸರ್. ಲೆಫ್ಟ್ ಸೈಡ್ ರೈಟ್ ಸೈಡ್ ಸರ್? ಇಲ್ಲ ಸರ್, ಏನಾಯ್ತು? ಹಾಂ ಓಕೆ ಸರ್. ಸರಿ.
ಇಲ್ಲ ಒಂದ್ ಸ್ವಲ್ಪ ಇನ್ಫಾರ್ಮ್ ಆಗ್ಬಿಟ್ಟಿದ್ರೆ ನೀವು
ಅದು ಡಿಲೀಟ್ ಆಗಲ್ಲ
ಯಾವ್ದ್ರಿ
ಈಗ ವಿಡಿಯೋ
ಆಗುತ್ತೆ ಡಿಲೀಟ್ ಆಗುತ್ತೆ. ಯೂಟ್ಯೂಬ್ ಅಲ್ಲೇ ಇದ್ದೀರಾ ನೀವು? ಯೂಟ್ಯೂಬ್ ಹೋಯ್ತಾ? ಲೈವ್ ಆನ್ ಮೊಬೈಲ್ ಓಪನ್ ಮಾಡಿ ಕಾಪಿ ಸ್ಟ್ರೀಮ್ ವಾಟ್ಸಪ್ ಮಾಡಿ. ಓಪನ್ ಮಾಡಿ ಫಸ್ಟ್ ಸೆಮಿಸ್ಟರ್ ಅಲ್ವಾ? ಫಸ್ಟ್ ಸೆಮ್ ಬಾಯ್ಸ್. ನೆಕ್ಸ್ಟ್ ಫಸ್ಟ್ ಸೆಮ್ ಗರ್ಲ್ಸ್. ಫಸ್ಟ್ ಸೆಮ್ ಗರ್ಲ್ಸ್ ಓಕೆ ಬಿಡಿ, ನೀವು ಸ್ಟಾರ್ಟ್ ಮಾಡಿ. ನಂದ್ರಲ್ಲಿ ಬಂದಿರುತ್ತೆ, ನಾನು ಕಳಿಸ್ತೀನಿ. ಓಕೆ ಫಸ್ಟ್ ಸೆಮ್ ಬಾಯ್ಸ್ ಕಳಿಸ್ತೀವಿ, ಗರ್ಲ್ಸ್ ಕಳಿಸ್ಬೇಕು. ಫಾರ್ವರ್ಡ್ ಮಾಡ್ಬಿಡಿ. ಅಲ್ಲಿ ನಾವು ಮೆಸೇಜ್ ಸಿಕ್ಕಾಬಿಟ್ಟು ಒಂದು ನೈಟ್ ಇಲ್ಲ, ಅದು ಹಿಂದೆ ಹೋಗಿದೆ ಗ್ರೂಪ್.
Good morning, students. First of all, wish you happy new year to all of you. This year gives a fabulous and joyful life for you. Today we are discussing about collision. In previous class, we discussed about momentum and linear momentum and conservation of linear momentum for a single particle and for a two particles and for a system of particles. Today we are discussing about collision. Collision. In a PUC, you learned about collision. Collision is nothing but when two particles interact with each other. Then we call it as a collision or a If one particle can collide with another particle and the another particle changes its direction or changes its velocity or changes its momentum or kinetic energy. So that we call it as a collision. Collision is nothing but the interaction between two interaction between two particles or two objects. If, for example, one body collides with another one, what happens if our body collides with another body? That means there will be a change in its shape or a force exerted on one particle to the another particle. Then the shape of the particles may change or they change their direction. For example, if I am considering two balls, they are moving on frictionless space or a frictionless plane space surface. Then, if this body having great mass than this body or this ball, what happens if it moves with the initial velocity u1 and it moves with the initial velocity u2? It means if it having great initial velocity compared to the second one ball, what happens if it moves on? If it goes on increasing, then the two particles what happen? Interact. This interaction we call it as a collision. Collision is nothing but the interaction between two objects or two particles. Okay. What happens if two objects interact with each other? The force exerted on first particle due to second particle and the force exerted on second particle due to first particle. They are in equal magnitude but opposite in direction according to Newton's third law. So this is about collision. And here I already told in collision there are some quantities has changed. What are those quantities? The momentum has changed, kinetic energy, and direction and velocity or shape. These all are the quantities which changes due to collision. So here in collision there are two types. We have classification of the collision. There are two types of collision. Types of collision. First one, elastic collision. Elastic collision. Second one, inelastic collision. So first we discussed about elastic collision. What is elastic collision? Elastic collision is nothing but the here in this collision the kinetic energy and linear momentum both are conserved. It means linear momentum before collision is equal to linear momentum after collision. That we call it as a conservation of linear momentum. In the same way, we can define kinetic energy. Kinetic energy of the particles before collision is equal to the kinetic energy of the particles after the collision.
It means there is a conservation of linear momentum as well as kinetic energy in the elastic collision. If I consider it in a inelastic collision, in inelastic collision, linear momentum is conserved, but kinetic energy is not conserved. Here, there will be a change in the kinetic energy after collision. It means linear momentum is conserved here, but kinetic energy is not conserved. It means kinetic energy before collision is not equal to kinetic energy after collision. So kinetic energy before collision is not equal to the kinetic energy after collision. It means there will be a decrease in the kinetic energy after the collision. That's why we call it as a inelastic collision. So first we write the statement or definition of the elastic collision. What is elastic collision? In this collision, both kinetic energy and linear momentum is conserved. Is conserved. It means that two particles which do not stick together. Two particles do not stick together after collision. After collision. Example. What are the examples for the elastic collision? For example, if I throw the ball at the wall, it comes back. It means it doesn't stick to the wall. This is a elastic collision. And how much initial velocity you given to the ball, how much initial velocity you given to the ball, that much velocity, final velocity means you will get the reaction in the same manner. It means the final velocity is also same compared to the initial velocity. So, if this is a ball, if I take the ball and if I hit the ball to this wall, what happens? It comes back with the speed or with the velocity, how much you given to the ball initially. So the collision momentum before collision is equal to momentum after collision. And here one more observation you observed here. The ball which do not stick to the wall. It means two particles do not stick together after collision. So this is elastic collision. So what are the examples for elastic collision? Collision between all the macro particles. It means collision between all the big particles are the examples for elastic collision. It means collision between two balls or collision between a bus and truck and collision between all the vehicles and collision between ball and bat and collision between those two stars or galaxies or planets, whatever it is. There is a big, if we consider a macro particles are nothing but the big particles. So collision between macro particles are the examples for the elastic collision. collision between macro particles. Macro is nothing but the big particles. And collision between the molecules of a gas. If I consider this room, there is a plenty of molecules of these gases here. They have to be collide each other and they will not stick together. It means collision of the molecules of a gas is also example for elastic collision. So collision of molecules of gas, collision between molecules of gas. And third example, collision between the subatomic particles. Collision between subatomic particles is also examples for the elastic collision. Collision between subatomic particles. Subatomic particles like a nucleus, neutrons. So, collision between subatomic particles are the examples for elastic collision. So, in elastic collision, what is main here? Kinetic energy and linear momentum has conserved. So, this we call it as a elastic collision. Next, we have to discuss about inelastic collision. So, second type, inelastic collision. Inelastic collision. What we have told, what I told here, inelastic collision means the collision between two particles takes place when linear momentum is conserved but kinetic energy is not conserved. So in this collision, linear momentum is conserved. Linear momentum is conserved, but kinetic energy is not conserved. Is not conserved, and nothing but the kinetic energy before collision is greater than the kinetic energy after collision. What it means? Kinetic energy before collision is greater than kinetic energy after collision. It means kinetic energy after the collision is less compared to the before collision. Okay? Means there will be a decrease in the velocity. And one more here. Here, if two particles collide, they will be stick together. After collision, what happens? They will stick together. So two particles after collision, they will stick together. Stick together. So now what is the examples for inelastic collision? First I consider collision between proton and electron. Collision between proton and example for inelastic collision. And second example, if I throw the bullet to the hard target, if I throw the bullet for the hard target, what happens? It will stick in that target. If I throw the bullet to the wall or to any man, if I fire a bullet for any man or any human, what happens? The bullet will be go inside the body of the human. Or if I consider the hard target or a wooden target here, okay, wooden plane. If I take the wooden plane, if I target the bullet, if I hit the bullet for this wooden plane, what happens? This bullet will stick to the wooden plane. It means it will not come back. So this we call it as an inelastic collision. Here see what happens? We give the initial velocity for the bullet, but the final velocity is a zero here because it is not zero. It is less than initial velocity. It means along with this wooden plane, the bullet will be moved some interval or some distance. Okay, so it means when after the collision, the two particles will be stick together. That we call it as an inelastic collision. Okay. Hitting of the bullet on the or at the wooden plane, it will stick to the plane after collision. So this is the example for inelastic collision. So we cleared about the elastic collision and the inelastic collision. Difference between the elastic collision and elastic collision. It is nothing but the inelastic collision. In elastic collision, linear momentum is conserved, but kinetic energy is not conserved. So if I consider the collision between two particles, if I consider the collision between two particles, what are the quantities will be changed here? So collision between two particles. Collision between two particles. If I consider two particles having masses m1 and m2, if I consider the two particles or two balls, two smooth balls moving on the frictionless surface, so the first particle having the first ball having the mass m1 and second ball having the mass m2, and they have the initial velocity u1 and u2. They move with the initial velocity u1 and u2. Actually, in collision, what are the quantities has changed here? So kinetic energy is changed, linear momentum changed, velocity changed, and direction changed. So after the collision, what is the velocity of these two particles? We have to find out here. So if goes on moving on the frictionless surface, what happens? particles will be interact or collide, and they exert the force in a equivalent opposite direction. They exert the force equivalent opposite direction. So this is before collision, and this is collision. So what happens after collision? They will move with a certain velocity. They will move with a certain velocity. They will move with a certain velocity. That velocity we take it as a v1 and v2. So this is after collision. So what I did here, I am considering the two particles having the masses m1 and m2, and their initial velocities are u1 and u2. Okay. After the collision, they exert the force on two particles. The F1 is nothing but the force exerted on the second particle due to first particle, and F2 is nothing but the force exerted on the first particle due to the second particle. They are in equal magnitude but opposite in direction. Okay. So what happens after the collision? They will move with a certain velocity. So that final velocity or the velocity after collision we take it as a v1 and v2. So v1 is the velocity of the first particle after collision, and v2 is the velocity of the second particle after the collision. So what are the given points here? We know about the masses of two particles and initial velocity of the two particles. So we have to find what is the velocity after the collision. So what is our aim here? To find velocity of two particles, velocity of two particles or two balls after collision. So this is our aim. So according to the conservation of linear momentum, what can we write? Momentum before, linear momentum before collision is equal to the linear momentum after collision. What is the equation for momentum? P is equal to m into v, mass into velocity. So if I apply for these two particles before collision and after collision, what happens here? So according to conservation of linear momentum, according to conservation of linear momentum, conservation of linear momentum, what can I write? Momentum before collision, momentum before collision is equal to momentum after collision. Momentum before collision is equal to momentum after collision. That is m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. So this is equation number 1. Consider equation number 1. So according to the conservation of kinetic energy, we can write equation equations according to conservation of kinetic energy. What you will write? Kinetic energy before collision is equal to kinetic energy after collision. So what you will write? The equation half. So what is the equation for kinetic energy? Kinetic energy is equal to half mv square and the momentum is equal to m into v. So half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. So consider equation number 2. So just write down those. So what is the first equation? m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This is the equation number 1. And what is the equation of number 2? m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square. This is equation number 2. So equation 1 can be written as m1 terms, take it up, LHS slide, and m2 v2 minus m2 u2. So this m1 take the common, u1 minus v1 is equal to, if you take the m2 common, v2 minus u2. So consider equation number 3. So in the same equation 4 can be written as like equation 3. So equation 4, equation 2 can be written as m1 u1 square minus v1 square, m2 v2 square minus u2 square. So consider equation number 4. So next, divide equation 4 by equation 3. Divide equation 4 by 3. So what is the equation number 4? m1 u1 square minus v1 square divided by m1 u1 minus v1. This is equal to m2 v2 square minus u2 square divided by m2 v2 minus u2. So this is a square minus b square. This can be written as a square minus b square. It is nothing but a plus b, a minus b. Okay. So what can you write? m1 and m1 get cancelled, m2 cancel each other. So u1 square minus v1 square can be written as u1 plus v1 into u1 minus v1 whole divided by u1 minus v1. This is equal to say v2 plus u2 v2 minus u2 whole divided by v2 minus u2. So u1 minus v1, u1 minus v1, v2 minus u2, v2 minus u2 cancel each other. What are the remaining terms? u1 plus v1 is equal to v2 minus u2. So this equation can be written as, or consider this is equation number 5. So 1, 2, 5. u1 minus u2 is equal to v2 minus v1. So consider equation number 5. I just interchange the terms here. u1 minus u2 is equal to v2 minus v1. It is nothing but this is the equation of the relative velocity before collision and after collision. This equation gives the relative velocity before collision and after collision. So with the help of this equation, you have to write down v1. v1 is equal to v2 minus u1 plus u2. So what I do here, I am just interchanging the terms. So v2 minus u1 plus u2. So if I write v2 is equal to v1 plus u1 minus u2. v2 is equal to v1 plus u1 minus u2. So consider this is equation number 6 and this is equation number 7. So substitute value of v2 in equation number 3. What I am doing here, substitute the value of v2 in equation number 3 and we have to simplify the value of v2. We will get the value of v2 here. Sorry, we will get the value of v1. What we are doing here, we have to substitute the value of v2 in the equation number 3 and we will get the value of v1. So just substitute v2 in the equation number 3. What is equation number 3? m1 u1 minus v1 just to substitute the value of v2 here. So m1 v1 is equal to m2. What is the value of v2 here? v1 plus u1 minus u2 and one more minus u2. And just simply substitute v2 in equation number 3. Okay. m1 u1 minus v1 as it is, m2 in the place of v2 we have to substitute. If v1 plus u1 minus u2 and one u2 is present here. So just simplify this one. m1 u1 minus m1 v1 is equal to m2 v1 plus m2 u1 minus 2 m2 u2. u2 minus u2 is equal to 2 u2 and m2 multiplied. So just take the terms, u1 terms. u1 is equal to u1 into, just take the common terms outside. u1 minus m1 minus m2. What I am doing here? Just I am taking the u1 outside. So m1 minus m2 minus 2m2. Take it to LHS. It becomes plus 2m2 u2. Take the minus m1 v1 to the RHS. So v1 is equal to m1 plus m2. So just look at this equation. What I have written here. First I substitute the value of p2 in the equation number 3. I just simplify this equation. m1 v1 minus m1 v1 is equal to m2 v1 plus m2 u1 and 2m2 u2 minus 2m2 u2. Just I am taking this term to the LHS. What happens? m1 u1 minus m2 u1. It is nothing but the take the u1 common here. So remaining term m1 minus m2 and minus 2m2. Take it to LHS. It becomes plus 2m2 u2 is equal to v1 term. Just minus m1 v1 take it to RHS. It becomes v1. Take the common v1. We will get the m1 plus m2. So just simplify that equation. So just we want v1 value. So it becomes v1 is equal to m1 minus m2 divided by m1 plus m2 into u1. Okay. Plus 2m2 divided by m1 plus m2 into u2. So consider this is equation number 8. So consider equation number 8. So next, substitute v1, value of v1 from equation 6. Substitute value of v1 from equation 6 in equation 3. In equation 3. What is the equation? m1, that is equation, just I am writing the third equation. m1 into u1 minus v1, m2 into v2 minus u2. So what I am doing here, just substitute the value of v1 from equation 6. So what is v1 value? m1 u1 as it is minus v2, because minus here, plus u1 minus u2, and the remaining term as it is m2 V2 minus U2. So just simplify this one. 2m1 q1 minus m1 v2 minus m1 u2 is equal to m2 v2 minus m2 u2. So again we are simplifying the v2 terms here. So just consider the u2. Just take the u2 outside. So just in model m2 v2 plus m1 v2 as it is. Just I am considering this m1 v1 to the other side. The remaining term minus 2m1 q1 minus m1 u2 plus m2 u2. Just I am considering the simplifying the terms here. So take the minus sign outside. It becomes m1 q1 plus m1 u2 minus m2 u2. It becomes 2m1 q1. You to take the common as it is m1 plus m1 minus m1. So if I take the v2 common here, what happens? m1 plus m2. So again I am writing the value of v2. So what is the value of v2? v2 is equal to, just take the first u2 term, m1 minus m2 divided by m1 plus m2 into u2 plus 2m1 plus m2 into u1. So just I am writing the value of v2. What we are finding here? The velocity after the collision after the collision of the first particle and the second particle. So consider equation number 9. So this is u1. So we have to find the equations for the velocity of the first particle after the collision and velocity of the second particle after the collision. If we know the values of the masses and initial velocity, we can find the velocity after the collision. So here 3 special cases are there. Just consider the special cases here. Special cases. First case. If m1 is equal to m2. If masses of the two particles are equal. So equation 8 and 9, what happens? Equation 8 and 9 becomes. Equation 8 and 9 becomes. V1 is equal to, what happens? Just look at here. M1 minus M1. M1 is nothing but the 0. M1 term is 0. Here 2m divided by 2m. It is nothing but the only u2. So v1 is equal to u2. So if I Consider the M1 is equal to M2. It means the masses of the two particles are same. If I substitute M1 is equal to M2 in this equation number 8, what happens? Equation 8 becomes V1 is equal to U2 and V2 is equal to what happens in the equation number 9? Again, M1 minus M1, this U2 term becomes 0 and here 2M by 2M. It is nothing but the 2M1 by 2M1. Nothing but the 1 into U1 is nothing but the U1. So, if the masses of the two particles are same, after the collision, what happens? They interchange their velocities. They interchange their velocities. It is nothing but the velocity of the first particle after collision is equal to the velocity of the second particle before collision. Is nothing but the first particle gets the initial velocity of the second particle, and here look at this equation. V2 is nothing but the velocity of the second particle after the collision is equal to the velocity of the first particle before the collision. Is nothing but the velocity this second particle after the collision, second particle gets the velocity of the first particle, initial velocity of the first particles. So this is the first case. Second case, if M1 is moving and strikes or it collides with M2 and it is at rest. M2 is at rest. Is nothing but the velocity before collision is equal to 0. Velocity before collision is equal to 0. Means if M1, just write, if M1 collide with M2, which is at rest, is infinity, U2 is equal to 0. It means initial velocity before the collision of the second particle is 0. So if the equation 8 and 9 becomes, if I substitute the U2 is equal to 0 in equation 8 and 9, what is the value of V1? So this term will become 0. What is the remaining term? M1 minus M2 divided by M1 plus M2 into U1 and V2. What is the value of V2? This term becomes 0. So it becomes 2 M1 by M1 plus M2 into U1. So velocity before after the collision of the first particle is the quantity of this one, and the velocity of the second particle after the collision is become 2m1 by m1 plus m2 into u1. And next, third case, we are considering m1 is third case. M2 is very heavier than M1. M2 is very heavier than M1. M2 is very heavier than M1, and then U2 becomes 0 and M1 is neglected. See about this case. If what I am considering here, M2 is having the higher mass than the M1. It means if I am considering the burst and the cycle. So this is M2 and this is M1. So what happens if cycle collide with bus? Alright, cycle interacts with bus. Alright, if you are considering day-to-day life, we consider it as an accident. This cycle hits the bus. What happens? There is no changes in the direction or velocity of the second particle because the mass of the bus is very heavy compared to the mass of the cycle. It means M2 is very heavy compared to the M1 and there is no changes and it is at rest. M2 is at rest. It means there is no initial velocity before collision and there is no collision velocity after collision because there is no changes happened here. If the M1 this cycle hits to this bus, so what happens? M2 is very heavier than M1 and then U2 is 0 because it is at rest and M1 is neglected because compared to the mass of the bus, the mass of the cycle is very negligible. So M1 is neglected. So what is the equation 8 and 9? Equation 8 and 9 becomes equation 8 and 9 becomes. So V1 is equal to what I do here? M1 is neglected. M2 by M1 is nothing but the U1. V1 is equal to U1 and here 2M2 by M2 is nothing but the So this because U2 is 0 here, so this whole term becomes 0. So V1 is equal to U1 and V2. What is the value of V2? Just look at the equation. This U2 term 0 and mass of the first particle is neglected. So the equation becomes V2 is equal to what happens? M1 mass of the first particle is neglected is nothing but the 0. V2 is 0. So V1 is equal to U1. What happens here? If I consider a bus here and it is a cycle. If it hits to the bus, it having the initial velocity u, cycle having the initial velocity u, and the bus having the initial velocity as 0, and this is u1. What happens if it collide with the bus? There will be a changes in the velocity of this cycle after the collision. So there is no changes in the velocity of the bus before collision and after collision. And M2 is very heavier than M1. So velocity of the first particle before collision is equal to the velocity of the first particle after the collision and V2 becomes 0. These are the special cases involved in the collision between two particles. So next class we discussed about elastic collision in the laboratory frame of reference and in the center of frame of reference, center of mass of a frame of reference. So before going to that, we have to know about the frames of reference. So next class we discussed about frames of reference and types of reference, and next elastic collision, how the particles work in the laboratory frame of reference and the center of mass of a frame of reference, and in elastic collision what are the changes in the laboratory frame as well as center of a frame. So we will discuss in the next class.
ಇಲ್ಲದಲ್ರಿ ಇವನ್ ತೋರಿಸ್ತೀನಿ. ಇದ್ರ ಮೇಲೆ ಒಂದ್ಸಲ ಕ್ಲಿಕ್ ಮಾಡ್ರಿ. ಇಲ್ಲೈತಲ್ರಿ ಎಂಡ್. ಈ ಎಂಡ್ ಮೇಲೆ ಒಂದ್ಸಲ ಕ್ಲಿಕ್ ಮಾಡ್ರಿ. ಇದಾದ್ಮೇಲೆ ಮತ್ತೆ ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಒಂದು ಬರುತ್ತೆ ಎಂಡ್ ಮೀಟಿಂಗ್ ಫಾರ್ ಆಲ್ ಅಂತ ಬರುತ್ತೆ.